Chapter 13, topic 13.5, problem solving. We will first look at the solved problem from the slide and then we'll work on in-class exercise 2. So let's read this problem from slide topic 13.5. The 10 kilogram ball has a velocity of 3 meters per second when it's at A along the vertical path. So it's here and then the velocity is given as 3 meters per second. Find the tension in the cord. So this ball is attached to the center using this cord. We need to calculate the tension force in the cord. So when we draw free body diagram, the tension force is going away from the ball, so that's tension T, and the increase in the speed of the ball. And we also need to calculate what will be the speed of the ball, the acceleration of tangential acceleration of the speed of the ball. The plan is since the problem involves the curved path and requires finding the force perpendicular to the path, we will use normal tangent coordinates. Draw the ball's free body diagram and kinetic diagram. Apply the equation of motion in the normal tangent direction. So first step is we define the normal and direction for the normal and tangential axis. So this ball rotates in clockwise direction. So at this point, tangential axis is tangent to the curved path. So this is direction for the t-axis. Normal is perpendicular to tangent and always towards the center of curvature. So this is normal axis. So we have defined our normal tangential coordinate system. Now different forces that we need to consider are weight mg, which always x down, and tension in the cord T, which is at the angle as shown in the figure. So this is the free body diagram. We have weight W. So it doesn't matter whether you like draw this up or down, but weight W is in vertical direction. You can also draw this as W like this. So yeah, instead of this, and this angle is 45 degree. And then there is tension force T. And this is free body diagram. These are the only forces. Now as a result, ball experiences both tangential acceleration. So its kinetic diagram includes MAT and MAN, normal acceleration. And now what we need to do is we need to apply sigma ft equal to MAT and sigma Fn equal to MAN. So these are our equations of motion. We need to apply them along the tangential direction and normal direction. Okay? So when the equations of motion is applied along normal direction, then we get the value of tension force. And when we apply this equation along tangential direction, we get the value of tangential acceleration, which is 6.94 meter per second square. Okay. So going back once again here, along the normal direction, the forces are T and W sine 45. This is W, so this W can be resolved into two components. W cosine 45 along the direction of T and W sine 45 along the direction of N. However, this points in the opposite direction of N and T is in the direction of positive N. So it's T minus W sine 45, that's here, equal to normal acceleration. And we have studied that normal acceleration is V square divided by radius of curvature in chapter 12. So we have been given the velocity. We also know the radius of curvature, which is the radius of that circle. And then that helps us to calculate T. And sum of forces in tangential direction includes only one force, that is W cosine 45 is equal to MAT. That gives us the value of MAT, which is 6.94. Now we can work on in-class exercise 2, problem number 13.52. And here are our normal tangential coordinate equations. So sum of forces in normal direction is mass times normal acceleration, and normal acceleration is V square by rho. Sum of forces in tangential direction is equal to MAT, or AT is also called V dot, and sum of forces in binomial direction is 0. So step number one is when we need to define our coordinate system in 3 dimension, it's very important to have the correct direction for each axis. So for normal tangent binomial coordinates, we use right hand rule, where we point the first finger in the direction of positive T, point the second finger in the direction of positive N, then the thumb will give the direction for positive B, and that's the right hand. So you keep your first, second finger and thumb of your right hand perpendicular to each other, and You set your first finger and second finger in the direction of positive N and positive T, and orient your hand such that like those directions align, then thumb will give the direction of positive B. So let's read the problem statement here. A girl having mass of 15 kg sits motionless relative to the surface of a horizontal platform at a distance of 5 meters from the platform center. If the angular motion of the platform is slowly increased such that girl's tangential component of the acceleration can be neglected. This is very good information because AT is 0, tangential component of the acceleration. Determine the maximum speed which the girl will have before she begins to slip off the platform. The coefficient of static friction between the girl and the platform is 0.2. So what the problem is asking us is that the platform is at, when the girl is at the platform, initially the platform does not rotate, and then slowly platform keep on like increasing its speed. Now what holds the girl in place is the friction force between her body and the platform, and what forces her to slide off the platform is the centrifugal force it experiences because of the increase in speed. So the moment where the force she experiences in the outward direction balances the friction force, that's the moment where the girl is about to slip off the platform. Now, if the speed is increased further, this force will increase, but the friction will remain same. So girl will slide off the platform. And we need to calculate what speed of this platform V that condition will happen. Okay, so let's draw our free body diagram for this problem. Okay, so we consider the girl as a particle, so it says here, and at that point we define the coordinate system. The platform is rotating in this direction, so this is our tangential axis. Normal axis is always towards the center, and binormal is perpendicular to both of this using right hand rule, which in this case is vertically upward. So we have defined our coordinate system. Now the next step is indicate the forces. So weight of the girl W equal to mg will act downward. Normal force which acts by from the platform onto the girl will act upward, and when she begins to slip off, like the friction force that prevents her from sliding off acts in this direction, friction Ff. Okay, so these are the different forces that we have drawn in our FBD or free body diagram. Let's draw the corresponding kinetic diagram. Girl experiences MAN, normal component of the acceleration. So this is parallel to this line. It's the same coordinate system, but this is free body diagram and this one is kinetic diagram. Okay, so for kinetic diagram, girl experiences only tangential acceleration, only normal acceleration. MAT is 0 because it is given in the problem that there is no tangential component of the acceleration. So now it's time to apply equations of motion. So first equation of motion that we should apply. See, eventually the speed parameter that we are looking for, we will get from sigma Fn equal to Man. So let's look at this. This is what we are interested to determine, and that's in Fn. However, for sigma Fn, we need to know friction force because friction is the only force along normal direction. Friction depends on the value of normal force. Friction is equal to mu times normal force, so we need to know the normal force. However, normal force is along the binomial direction or binomial coordinate axis. So we start with binomial axis equation of motion. So sigma FB, sum of forces in binomial direction going up is positive, is equal to 0 because there is no motion of girl along vertical direction. Now normal force is going up, weight is going down, so that is 0. So N is equal to mg, which is in this problem 147.15 newtons. Mass of the girl multiplied by 15 kilogram multiplied by 9.81. The friction force Ff is mu times normal force or mu s static friction, which is 0.2 times 147.15, and that's 29.43 newtons. And now we apply the final equation. Sum of forces along normal coordinate axis is mass times normal acceleration. And there is only one force along normal, which is FF, friction. See, there is no other force. So FF equal to MAN, and it's M V square divided by radius of curvature, FF. Now, value of FF is 29.43, mass of the gull is 15 kilogram, velocity square divide by radius of curvature, and that's this. This is the radius of particle from the axis of rotation, which is 5. Okay. Therefore, V is, when you solve this equation, you get V equal to 3.13 meters per second. And that's the answer. Okay. So what it means that as long as this V is below 3.13, girl will stay on the platform. When V changes to more than that, for example, V is 4 meters per second, then the centrifugal force that girl experiences will be more than the friction force which keeps her in place. So she will slide off the platform if V is more than 3.13. Okay. So once again, we have used three equations of motion in appropriate order and calculated the required velocity.